So sometimes when we're given a regular polygon, all of the information that we have is what the length of the radius is. So let's talk through an example of how to solve such a problem, how to find the area of a regular polygon, only knowing the radius. Okay, so our first example is a stop sign is a regular octagon with a radius of 16.2 inches. What is the stop sign's area to the nearest square inch? Okay, so like in our last example, we are trying to find the area by taking 1/2 times the apothem times the perimeter. So we have to figure out how we can use trig to find the apothem first, and then we'll find the perimeter as well. Okay, so we've got a regular octagon. And octagons are my favorite shapes to draw because they just seem to work a lot better than my nonagon. So we're going to start off. We have a radius of 16.2 inches. And I'm going to start off by drawing one of our 8 triangles from inside of our regular octagon. And I'm going to split that triangle in half by our apothem. Okay, so now we have 2 right triangles. And I'm going to pull one of them out. So we've got our apothem. We've got our radius of 16.2 inches. And we're going to call this bottom side B. Okay. Now we know one side. We know our hypotenuse, but we don't know this angle. How can we find it? Well, let's call this whole angle inside of here C. Now remember, to find the angle of C, all we have to do is take 360 divided by the number of sides of our polygon. So I'm going to just do that up here real quick. So the measure of angle C was 360 degrees divided by 8, or 45 degrees, right? So if this angle is 45, and we cut this triangle directly in half, we bisected it, this angle is going to be half of 45, or 22.5 degrees. Okay. So now that we have this, we can find our apothem. So since we have the adjacent side and the hypotenuse, we can use our cosine function to find the apothem of this triangle. So that looks like the cosine of 22.5 degrees equals our adjacent side over our hypotenuse. And so to get A by itself, we're going to multiply the 16.2 over. So we get 16.2 times cosine of 22.5 degrees. Okay? And that is our A. Okay? So we have A, we have our apothem, and now we need to find P. We're going to leave this in, we're just going to leave the cosine in here for now, and we'll simplify it out later. Okay, so to find P, we need to know the length of one of the sides of our octagon. Okay? If we find B, that'll help us. So we're going to find B first. Okay? So we're going to find the length of one that since we pulled this triangle, this right triangle out of, by bisecting our original triangle, we know that B is only half of one side of our triangle. So in order to find the length of one side of the triangle, we actually have to multiply B by 2 to cover both halves of this side. So, in the words of Hamlet, to be or not to be, that is the question. But in this case, the answer to that question is yes. 2B is one side of our octagon. Okay, but first we have to find B. Now, in order to do that, we're going to use trigonometry again. But this time, if we're looking at our 22.5-degree angle, we're looking at the opposite side over the hypotenuse. So to find B, we're going to use sine. So we know that sine of 22.5 degrees is equal to B over 16.2. In other words, multiplying across, B is equal to 16.2 times sine of 22.5 degrees. And that's B. That 2B is going to be 2 times 16.2 times the sine of 22.5 degrees. And this is going to represent the length of one of our sides. To that out, we find that the length of one side of our octagon is going to be about 12.4 inches. 12.4 inches. So then when we want to find the area of the perimeter, we need to take the length of one of our sides and multiply it by the number of sides of our polygon. And in the last part, we found that one side was 12.4 inches. Now, to find the perimeter, we're just going to multiply 8 times the side length, which is 8 times 2b, which is 8 times 12.4 inches. And that gives us a grand total of about 91.2 inches. So that's our perimeter. So we found our apothem and we found our perimeter. Now we're going to put the two together to find our area. Now that we have our apothem here and our perimeter here, we can now use these values to find the area of our stop sign. Okay? So the area is 1/2 times A times P. We have 1/2 times 16.2 times cosine of 22.5 times 91.2. And when we multiply that out, and round to the nearest ½ inch, we get that the area is 742 square inches. Okay, so you driver's ed students, now you know that the approximate area of a stop sign is 742 square inches. I bet you they didn't teach you that at driver's ed class. But let's just take a quick review of what we've done to solve for the area of a stop sign. We took one of our 8 triangles that make up a regular octagon. We used the apothem to cut it in half, and we created a right triangle that we used this right triangle and our cosine function to find the apothem. Then we used sine to find the length of B, which was one half of one of the sides of our octagon. So we found B, and then we multiplied it by 2 to get the length of one of the sides of our octagon. Then we multiplied this value that we got for one side of the octagon, multiplied it by 8 to find our perimeter. Once we have our perimeter and our apothem, we plug them into our area function and find that the area of a stop sign is 742 square inches.